So now that we've given an overview of completion stage methods, let's once again take a step back and look at completion stage methods holistically, not unlike what we did earlier when we looked at the whole completable future API holistically. And that's because there's a lot of these methods and we want to find a way to kind of chunk them up so it's easier to understand what they do and how you could apply them. Now, as you can see here, completion stage methods make roughly 2/3 of the total number of methods that are part of the completable future API, and so it helps to kind of winnow down a bit to see the forest for the trees here. We can group completion stage methods based on how a stage is triggered by one or more previous stages. And as you can see here, there's 3 different variants: completion of either of 2 previous stages, completion of both of 2 previous stages, and completion of a single previous stage. So within the 2/3 of the methods that are completion stage methods, it's roughly 1/3, 1/3, 1/3 into those 3 categories. And that again may just give you a little bit of comfort when you're trying to navigate this rather intimidating API at first glance. So let's take a look first at some of the methods that will be triggered upon the completion of a single previous stage. And there's a bunch of different ways to look at this particular diagram. What we're going to do here is we're going to first talk about the versions of these methods without the async after them. So we'll talk about then apply, then compose, then accept, and then run. And then we'll talk about the versions that have the async stuff there. So then apply is a method that takes a function and it returns a completable future with the result of the function once the operation gets a chance to run, and it'll only run when the previous stage completes. And the behavior is to apply the function to the result of the previous stage. So it returns a completable future with the result of that function after the previous stage runs. Then compose looks very similar. The main difference is that it de-nests nested completable futures. And I'll talk about this in a lot more detail because it's a very important method to understand. But the best way to think about it analogously is it's somewhat like flat map, where flat map takes a stream of nested things and de-nests them. So you can think of then compose as kind of the philosophical equivalent of flat map, although its behavior is somewhat different in other ways. It also applies the function that's passed to it to the result of the previous stage. So it looks a lot like then apply, but it has slightly different semantics because it de-nests stuff. And I'll show you an example to make that crystal clear. If you ever watched the movie A Few Good Men, you remember the phrase crystal clear. It's a great phrase if you ever watched that. The next method is then accept, and this is going to take a consumer and it returns a completable future with no value. So it's only there to be able to have some action run, but it doesn't actually return a result. It's typically used at the end of a chain of calls as the last one. And the consumer will handle the result of the previous stage when that stage result is ready. And finally, there's another method called then run, which uses a runnable, takes a runnable instead of a consumer, and also returns no value. Now, the methods that you see here either will run in the invoking thread, and those are the ones that are the then apply, then compose, then accept, then run, or they can also run in a different thread. So the async variants differ from the non-async variants because the async variants will most likely, almost invariably, run in a different thread of control. So they're going to be used to schedule to run in a different thread, whereas usually the then apply, then compose run in the thread of control as the previous stage's computation ran. And we'll see later there's various factors that dictate exactly where things run. But the bottom line here is that if you use the async versions, you're likely to use more threads, which could be good. Use more threads in the common fork join pool or some other thread pool that you're using, which could be good. You could get better scalability, or you could end up with more overhead. And so you have to kind of do some experimentation, and I highly recommend writing code to try different ways and see which runs best to decide which is going to be the appropriate way to go. The next group of completion stage methods that are triggered based on one or more previous stages are the completion stage methods that will complete when or what will be triggered when the completion of both of two previous stages finish. So you can think of these as essentially and, or essentially conjunction style completion methods. And there's a bunch of them. There is then combine, then accept both, and run after both. And there's an async variant of all these as well. So then combine takes something called a by function. And what that does is when both of the previous stages complete, then the by function is called. And a by function takes two inputs. That's what the by means. And it returns a result. So it'll apply the by function to the results of both of the previous stages and return a completable future to that. There's also then accept both, which takes a by consumer as opposed to a by function. And once again, it'll do the processing, but it does not return a value, unlike then combine. It just basically calls this side effect action. And then there's also one called run after both, which is very much like then accept both, except it takes a runnable, not a by consumer. And it'll run the given action when both previous stages complete. But it doesn't really take their results in any meaningful way. And it provides no output. So those are the ones that are the two previous stage versions, the conjunctive ones, the and variants. And we'll take a look at some cool uses of these. And then the third and final grouping of these completion stage methods are the ones that complete when either of two previous stages complete. So you can think of these as basically being logical disjunction, either or. So if one of two finishes, we'll take the one that finishes first. And you can see that there's three of these. There's apply to either, accept either, and run after either. And there's async and non-async versions of these. The apply to either takes a function, and that function will be applied to whichever of the previous two stages completes first, and it'll give back a completable future with the result of applying that function. There's accept either, which does not return a value, but will handle the results of either of the two previous stages and return a completable future to void. And then there's run after either, which does the same thing, except it takes a runnable, not a consumer. Question? Yeah, great question. So the question here is, does it run it on both of them or whichever one finishes first? It's whichever one finishes first. There's some subtleties to this, which we'll take a look at later. The other completable future will continue to run to its completion, but basically the function or consumer that's applied will apply to whichever one finishes first. Okay, so that's a quick overview of the different groupings of completion stage methods. And again, there are three of them. They're all dealing with handling results from previous stages, and the differences are whether there's one result we're waiting for or two results, and if there's two results, it's either both of them or the first of them.